So 8.5, we've gone halfway through with the determinants, and now we're going to come back and finish 8.5 with Cramer's rule. I don't know why I like Cramer's rule so much. I honestly, I just think it's a neat little trick, kind of. I mean, it's mathematical, but I still think it's kind of a trick. Augmented matrices work just as well, especially when you have your calculator with you, but I just kind of like to see how the determinants help us solve systems. So we're going to use Cramer's rule to solve a system. So let's solve a system. So we're going to let our system, now this is going to look a little bit weird, but we're going to let our system look like this. AX plus BY equals C, and then DX plus EY equals F. Yeah, no, that looks a little right. So there's our system, to solve a system. Now, Cramer's rule says this. So Cramer's rule says, let A equal the determinant of these little guys, the guys that have the X's and the Y's on them. So A is going to be the determinant of A, B, D, E. And A sub X, now the book uses different variables, but I like this, it kind of helps me see what's going on here. So what we're going to do is we're going to do another determinant. We're going to call this guy A sub X. And in A sub X, we're going to take these two values, the C and the F, and remember, this represents the X's and this represents the Y's. We're going to take the C and the F and we're going to replace them in the X column. So it's going to be C, and I'll do it vertically, F, and B, E. Okay. So we've got the original A, and then A sub X, we're going to replace the X column, the first column, with the answers. And of course I ran out of room. And A sub Y means we take the original guy, put the A and the D back in, but in place of the Y column, we're putting the C and the F. Okay? So we're taking the answers and we're replacing them in each column. So we've got three determinants here. So let A and AX and AY equal these things. Then X equals A sub X divided by A, and Y equals A sub Y divided by A. Done. So if we find three determinants and then two little fractions, the problem is done. So the biggest issue with here is making sure that you put the C and the F into the correct spots. So let me show you, let's get an example up here and we'll see what we got going on here. Alrighty. Now, here we've got 2x minus 3y equals 4, and we have 5x plus y, let me make sure I put that right, equals negative 2. Okay. Now, I know that we could multiply this guy by 3 and do some elimination, but the point here is to use Cramer's rule. So we're going to find these three determinants first. Okay, so let's go for A. And for this one, you really shouldn't need your calculator at all. So A is going to take just the numbers here. So the 2, the negative 3, the 5, and don't forget that's a 1. Now, we're looking at determinants, so we're going to go main diagonal, which is 2, minus opposite diagonal, which is negative 15. So 2 plus 15 gives us 17. Then we're going to find A sub X. And for A sub X, we're going to take the 4 and the negative 2, and we're going to replace them right there. So 4 and negative 2 get replaced right there. The negative 3 and the 1 stay put. And we find the determinant again. Main diagonal is 4, minus opposite diagonal is 6. So that one is negative 2. And one more determinant here, a sub y is going to equal, okay, now we're going back to the original first column, so the 2 and the 5 are going to be there, but the 4 and the -2 are going to sit right there. So, just like before, main diagonal, -4, minus opposite diagonal is 20, so this is -24. And as always, I round myself out of room, so I'm just going to come right back over here. So we found these 3 determinants, not so hard. Now we're going to make our fractions. So to find x, x is going to be a sub x, -2, divided by a, which is 17. That's an ugly fraction, okay? But we found it. Now y is going to be a sub y, which is -24, divided by 17. So the x and the y, the intersection point for this system, the answer to this system is -2, 17, -24, 17. Now, think about that. If we were solving this the old-fashioned way by hand, we could do it, but who wants to deal with fractions like that? In this case, did we have to deal with any fractions at all? No, we made the determinants and then we just put them in the formula and the fractions popped out in the answer. So Cramer's rule, while quick and easy, okay, can also help you if you're gonna have ugly answers. And you don't always know that from the beginning, but if you like Cramer's rule, it makes your life a lot easier if there are fractions. Now, Cramer's rule can work exactly the same when you have a bigger matrix, when you have a bigger system, so a 3-variable system of equations. The only issue is there, when you go to find your determinants, instead of doing them by hand, you're gonna go to your calculator. Now, I'm making the assumption that you looked at the last lecture, so you know how to do determinants on your calculator, but let's go ahead and just work through a bigger one with Cramer's rule so you can just see how it works. Okay, so let me turn the page. I'm trying to figure out what they did because it looks horrendous. That is not what we're doing here. So weird. This book is so weird, I swear. Okay, let's just pick one. Pick one at random. Okay, let's say that I give you 3x minus y is minus 2z, is equal to 10. And then 4x minus y plus z is equal to 5. And then x minus 3y minus 4z is equal to -1. Okay. And this is the guy that we want to solve, and we want to do this using Cramer's rule, not any of our other methods. So it means that we're going to create A, and A is going to be the determinant of just the originals. So we'll have 3, -1, -2, and 4, -1, 1, right, -1, 1, and 1, -3, -4. So we're going to find this determinant first. Now, I can't look at that and know what the determinant is, so I'm going right to my calculator as well. So take a minute here, go to your calculator. We're doing a 3x3, edit, and put in your numbers there. Be very careful. Let me look at it, make sure I've got it all correct. Okay. And then determinant of my matrix and I got 26 for this guy. Okay. All right, now we need to do a sub x. So for a sub x, we're taking these guys here and we're gonna replace them for the first column. Okay, so we're gonna replace them for the first column. So now the first column is gonna look like 10, 5, -1, but the other guys are gonna stay the same. -1, -1, -3, and -2, 1, -4. Now, if you go back in to matrix to edit your same matrix that you have there, you can use your arrows to go, and since we don't need to change all of them, we just need to change this one. When you get in there, you can use your arrows to go around and make the first one 10, and then use your arrow to make the second one down 5, and then the third one down -1. Okay, and then, but make sure that it went in correctly, you didn't change anything else. And then second quit, matrix, determinant, that is not what I meant to do, matrix, determinant, boop. And for this one, I got 83. Okay. Now we need to do a sub y. So another determinant. Now in this one, remember that the first column is coming back. So we have the 3, 4, 1, but the 10, 5, -1 is moving over into the y column. So 10, 5, -1, okay? And the last guy stays the same. Now, this one is gonna, it looks a little bit different, so maybe you want to redo the matrix altogether, or if you just want to go in and change things back the way they were, okay? But whatever you do, just make sure that as you go through, everything looks good. Okay, check it. Okay, mine looks good. Second quit. Okay, hopefully it's good because I got 131. Okay, so the determinant of this guy is 131. And then finally a sub z, which we didn't have to do in the last one, but we do have to do this time because there are 3 variables. So we need an extra matrix, okay? So we're going to have the 3, 4, 1 stays there. The middle column comes back, the -1, -1, -3, and the 10, 5, -1 slides over into the last column, 10, 5, -1. Okay, this is the last one, so only one more time in the calculator. All right, let's see. So, matrix, edit. Three by 3. Okay, check it again, make sure it's exactly the way it should look. Okay, mine looks good. Matrix, determinant, matrix. I'm using matrix B. And this one is -71. Okay. All right, so some ugly numbers going on there. So now if we want to figure out what x is, remember all we have to do is take the a sub x matrix, so the 83, and divide it by the original, 26. Now, that's no fraction that reduces nicely, so oh well, just leave it. And then y is equal, so we're gonna take this guy, 131, and divide it by the original 26. Again, I honestly don't know, so let me just see if 131 divides nicely by 26. No, it does not. Okay, so we just leave it just like that. And then finally, z is going to be equal to negative 71 over 26, and again, an ugly fraction. So here is a system that has its answers, x, y, and z, 3 pretty hideous fractions. So if we were doing this by hand, you know, like trying to eliminate the x's and then trying to eliminate a y, like we used to do, by the time we got to the end, we might be in tears, and I have serious reservations to say that we would get this right. I'm pretty sure that somewhere along the line we'd screw up with a fraction, and it's a good chance we'd get this wrong. But with Cramer's rule and the use of our calculator, as long as we check to make sure what we're putting in, it doesn't matter how ugly those answers are, boop, they pop out, okay? All right, so the big one, obviously you have to use your calculator, but the little guys with Cramer's rule, the two variable systems, they're pretty quick. So Cramer's rule is kind of it's a neat little trick by replacing the answer column in to find the x's and the y's. So I kind of like that one, right? Okie dokie, that's it for 8.5, we are done.